Alright, so in this video I'm going to take a little look at the basics of creating a structure. So here I created, and also showing how to work with multiple files, I created a header file here, right, .h file, and that's where I put my structure. So now I can include this header file anywhere else that I need to, and I can have access to this data structure. This defines a book, has 3 strings: title, author, genre, and the price of it. Right. And then over in my main, right, the basic structure, then again, keyword struct needs that semicolon after the closing curly bracket. So I can include a header file that I created. So when you create a header file, you don't put it inside the 2 brackets there, the less than and greater than, like we did with the IO stream up above. You put it in double quotes when it's a header file that you create. So that now allows me then to go ahead and create a book. Book's now a new data type. That's what a structure does for us. It gives us a new data type. And there I created a variable called book1. Its data type is book. And what that gives me access to now with the dot operator is the 4 data members that are inside a structure. Now remember, this does not allocate any memory, so there are no variables yet anywhere. Nothing's defined, so nothing's allocated. This allocates an instance of the structure. So now those 4 variables in the structure are allocated memory for this instance of it. It's called book1, and that's what I have access to. Alright, so now I can go ahead and set those variables to values if I wish. Alright, I'm just going to copy and paste a little from my notes here. Save a little time there. Right, so that gives me access again to all 4 members. So I can change the author, change the type of book there, the price, and the title of the book if I want. And now I can still access it. Right, I'm accessing it there to set the values in an instance of the structure, and there I'm outputting the data that's in that instance of the structure. Instance is important here. It's a creation of an object. We're getting towards object-oriented programming now. So this is creating, so when the structure defines an object, it has 4 data members, and there you see the data members are set, just as I did here in those statements, and then I output them with some basic outputs there, nothing fancy yet. So again, I created an instance. This creates an instance of the structure. The structure does not take up any memory until you create an instance of the object. Right, so keep working with that structure. We're going to create another one. This time I'm going to work with a pointer because we can create pointers to objects, and that's very common when you're programming. So if you're using a pointer, we got to create an instance of book using the new operator. So book2 at some point does need to be deleted. It is a pointer that's allocated with the new, so we need to do a delete book2 at some point. Lay that way towards the bottom there. And still the same thing, I can set the author, set all those things just like I did up there. I'll just do using that pointer. I'm going to create the exact same book, except now I'm using a pointer notation since I have a pointer. Alright, so I'm accessing the same 4 pieces of data within the structure with a new instance. These are 2 independent instances. Right? I can change any piece of this. Let's just change the price on, I did, there it is, $10.59. Up above it's $15.99. When I go ahead and let's put some output statements there now. Again, working with a pointer, so I can use a pointer everywhere now for that book 2. And there we get some output going. Should look similar to what we have up above, except now the price has changed. Everything else I left the same, and there's the output that you get. 2 different prices, 2 different instances, so whatever I change in one does not affect the other one. They are completely different instances. So with these structures, relational operators will not work on a structure. I cannot compare one structure to another, so I cannot do something like ask if book 1 is equivalent to the content at book 2. Right? It doesn't know what equality is, doesn't know what less than, greater than, all those things are, and how they work with these structures. Right? So it doesn't know how to compare objects, is what it's boiling down to. When we get to classes, you'll see how to get around that with classes. So if you really want to compare it to instances of a structure, you actually have to access the individual pieces of data. Just like if I wanted to compare the authors, I would have to access the author of book 2 like that, and access the author of book 1 like that, and then use the equality operator or any of the other relational operators. Alright, so just keep that in mind, doing comparisons with structures. Alright, so let's create a third instance of the book. This kind we'll call it book 3, and this is initializing a structure. With curly brackets, I can create an instance of the structure and start populating it. Oops. Alright, so that creates an instance of a structure, a book, and it sets the title to C++ OPP, Object-Oriented Programming. It sets the title because the title is the first thing listed in the structure. So it assigns that string to that. So if author was first, the author would be C++ OOP. Right? So if I was to go ahead and do these statements on book 3, change these to book 3 here. Oh, these aren't pointers, so I gotta put dot in there. Alright, so by doing this now you'll see a couple other things going on. There we go. So in the output now, once it's done compiling, there we go. Alright, there's that new book. You see the 0 there for the price. The author is null, so it prints nothing, and the book type of the book is also null, so it prints a null out or nothing. Alright, so the numerics got initialized to a 0, whether the non-numeric values got set to a null. Alright, so that's one way to initialize, and again, we can keep initializing. We're creating the books. Alright, so here we're creating another book. Alright, bring that code over there. Initializing it, so there's a book. I'm initializing the title to Learning C++ and the author to myself. Alright, so now if you keep going with the same format of our outputs, again you're going to see now that two pieces of the book are initialized. Well, actually, they're all initialized, but the two are initialized to the values I put in the parentheses. Again, the order that they are in the parentheses we'll assign it to the order they are in the structure. Again, looking at the structure, this is a header file that I have called books.h. I just now realized you can't see that. But two things were passed in, two strings, so it automatically sets it to the title and the author. If I try to pass in a double first, it's going to complain because it doesn't know how to assign a double to a string. It's always going to assign them in the order they're listed there. Alright, so you can also create an array of books. Books is just a data type. Alright, just like any other array, you need a data type, and you need to give it some kind of size here. Alright, so there you're going to create 4 books. Alright, I can populate those books. I have 4 books up above created, so I can come in right now and populate my array with those books. Book 1, book 2, book 3, book 4. Book 2 again is a pointer, so I have to put the asterisk up front to actually get the object, the instance. Right, and now I have an array. Right, a structure defined a new data type. You're defining what that data type is with a structure. And similar is going to happen with classes. So I just added a for loop that will print out all the data that's in the array, so we'll see the same 4 books print. Right, with the same missing data for those 2 that we initialized, and then populate all the data members. Alright, and let me bring that over there. So, alright, so there's the book, with me being the author, learning C++, there's the book of C++ OOP with no author. And then the other two books, where the difference between them was just the price. All right, so that's an array of objects. All right. Very important concept as we move forward, especially with classes as we move forward. So there are 4 instances here. These are independent of these 4, right? This array has 4 instances of book, and I assign 4 different instances to those 4 instances. All right. So an instance is a creation of an object. In this case, the object is the structure, in this case being book. We can create array and initialize the array. Right? Remember, each location in an array is creating an instance. So the same way I created or initialized, oops, sorry there, missed part of that. The way I initialized the structures above, I can do similar with an array. All right, so here I'm creating another array called books2. It also has 4 items, but the books now are there. It has a title 1 by Tom Jones, title 2 by Mary Jane, it's sci-fi, title 3 by Mickey Mouse, it's a fiction, it has a price. Right, so these curly brackets is the same thing we did up above here with the curly brackets, except now it's inside another set of brackets. So this set of curly brackets defines a book. Right, each one of these is a book, so there's 4 of them. This curly bracket says we're initializing the array to those 4 books. Right, so I can add the loop again here and using that array now to output, and we now have those 4 new books on our output. So again, now it's an array of objects. The object type is book, and we have access to the 4 books. Right? They each initialize differently. Right? This has the author and that's it. It was just the author. This one I gave it the author and the type of book that it is. If you look back here, oops, the title, the author, and the type of book, the title, and the author there. Right? The 3rd book had the title, the author, the price, and the type of book. The 4th one just had the title. Right? So again, in these 3, the price was set to 0 because the variable was created, so it automatically initializes it to something for you. Right, so again, a structure defines an object, so you have to create an instance for the structure to be allocated, and then we can access the data members with the dot operator. If we create a pointer to the structure, then we use the pointer note operator there. I have a file called books.h, which is where I define this, which then means I can include the .h, right, which has the books.h inside of it, in double quotes, not the less than and greater than operators.